Areas, section 1. In here we are gonna go over only few simple shapes, and they include square, rectangle, triangle, regular polygon, circle, parallelogram, rhombus and trapezium. Okay, so the first thing that we are going to do is define area, and we are going to do that by saying the following statement. Area is the measure of the extent of the surface with measurements made in unit squares. What does that mean? It means we are going to select a unit square, and it can be in meters, centimeters or anything, but it has to be a unit square with sides measuring 1 with whatever the measurement that you are using. So now by covering the entire surface of the surface that you are measuring with these unit squares, we get the area of that surface. And you might have a question that what if we can't fit in the unit squares to get an area of the surface? Then we're going to increase our resolution of the unit squares, which is at currently 1:1 to a resolution which enables us to find the area of that required surface. Now let's go through those shapes that I was talking in the beginning, and we will start with square. So if n unit squares can be accommodated in a square with sides length L, then the area must be equal to n, also L into L. So second, rectangle, and again if n unit squares can be accommodated in a rectangle with length L and breadth B, then the area must be equal to n, also L into B. Third, triangle. First we will consider only right angle triangles, and then we are going to generalize it to all triangles. So if n unit squares can be accommodated in a rectangle with base B and length L, then the area of the right angle triangle is half L into B, or half n. And as this is the case of right angle triangle, we will replace the length with h. Now to all triangles, indeed the formula won't change, as it can be seen as two right angle triangles joined together. Fourth, regular polygon. In here the area can be summarized as the sum of all the triangles, half L into h into n, where n is the number of triangles. And it can also be written as half h into p, where p is the perimeter or the length of the total enclosure. Fifth, circle. Circle is a special case in regular polygon where the polygon number goes all the way to infinity, and the area is half into h into 2 pi r, where 2 pi r is the perimeter of the circle. Sixth, parallelogram, where opposite sides and opposite angles are equal, and in fact it can be arranged into a rectangle, making its area to be width into height. Seventh, rhombus. It is like a parallelogram with one more rule added to it, and that is all the sides are of equal length, so area it won't change. Eighth, trapezoid. The last one, this might not look like a parallelogram, but just a sec. And as you can see, we have to reduce the area by half, as we totally made it up. Now let's move to section 2, problem 1. Find the cost of carpeting a room 13 meters long and 9 meters broad, with a carpet 35 centimeters wide at the rate of rupees 12.4 per square meter. Okay, we got a room with size of length 13 meters and width 9 meters, and he mentions that there is a carpet of 75 centimeters width, which has to cover the whole area of the room. Now let's calculate the area of the room, and then we will see how long should be the carpet to cover the whole area by equating the area of the room to the area of the carpet. Problem 2. A room 5 meters 55 centimeters long and 3 meters 74 centimeters broad is to be paved with square tiles. Find the least number of square tiles required to cover the floor. Step 1. Laying out the picture. So we got a room size of length 5 meters 55 centimeters and width 3 meters 74 centimeters, and he wants this room to be covered by square tiles such that they all fit perfectly without any overshoots or undershoots, and he also wants the number of tiles used to be kept at minimum. Step 2. Find the relation and solve. So the criteria number 1, without any leftovers, can be satisfied in many ways. You can use the tile size of 2 centimeters, 17 centimeters and so on, but the criteria number 2 is the one which pinpoints exactly what to use, and it does it by finding HCF, highest common factor, of 544 and 374. because to pick the tile size, it's not just enough to pick any factor of 544 and 374. We have to pick the highest factor among them to reduce the number of tiles. So we choose 34. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.